Good morning. Can you hear me okay? Am I on? All right. I want to thank the Vintage Report for having me back. It's always a pleasure to come back to this region. I grew up over in Marin, and so being able to come here, get to see some friends. And I also want to thank Nova. Appreciate your talk. We're going to have a little bit of overlap, but it's going to be very complimentary, okay? So what I'm going to do here today is what I've done previously in a similar kind of framework here is we need to talk a little bit about the past year, and some history there. We'll talk a little bit about the current conditions, and then we'll look to see what that can tell us about the spring and the coming summer in terms of this next year. So we need to talk a little bit about the state of the climate, kind of where we are overall. The basic perspective, of course, is that the data is just out now from all of the worldwide agencies. 2019 ended up the second warmest year on record. However, I do want to point out something that's in that map there that's really important for us here. The coldest area departure from normal on the globe in 2019 was in central North America. And that was really what has been, I think, driving much of what we've been seeing for the past two vintages here. Not quite as warm as it would have been otherwise. And I'll show you some more about that here in just a minute. We also know that 2019 was the warmest year on record in the world's oceans. We also know that 2019 was the warmest year in the Arctic, and both poles are losing ice mass at record paces. If you look at some of the data, historically we've had multiple different agencies that have put out long-term data for the globe. These are all starting to line up, and the reason I'm showing you here this is you can see as we look toward the more current data overall, US, Japanese, European, all of the major agencies are now measuring the Earth in much more precision than I think we've ever done. And you can see where we are in terms of plus 1 degree Celsius above normal in the most recent period. This is a map of the United States. This is just looking at mean temperature percentiles. And you can see here this very cold region that we've seen in the upper plains. This extends up into Canada. And I think that this mass of cold air has really been kind of keeping us a little bit down in terms of temperatures pretty much throughout the West. And if you go into the inland Pacific Northwest, Idaho, Eastern Oregon, Eastern Washington, they have been quite impacted for the past couple of years. Nova, South Carolina, just had one of its warmest, driest vintages ever. They don't grow a lot of grapes there, but you know, it really was. It was an extreme warm year for that part of the United States. So if you look at it on total, we were overall as a country, the continental United States, we were warmer than average, but it ranged from being 1.2 degrees Fahrenheit below to 2.7 degrees Fahrenheit above. The southern part, of course, is warmer than the northern areas, but this ended up being the 23rd consecutive year above average for the United States. I'm not showing Canada or Alaska. Alaska was much above normal overall. The other thing that I think Nova mentioned, which is really important here, and I'm not showing the maps for it, is that minimum temperatures in the United States were up almost twice the amount that maximum temperatures were up. And that's the humidity key that we have. And we'll talk a little bit more about that here in a minute because it's really tied to the oceans. So this is a map just looking at longer term trends. I just wanted everybody to have a sense of kind of what's happening. This is June through August in California as a whole. And the overall trend over this 120-year plus period is 2.3 degrees Fahrenheit during that time period. All growing regions, and if you look at the map of California right there, those are what are called climate divisions in California, but in the rest of the United States. We use those to help organize data regionally. And all regions in California have warmed 1.8 to about 3.1 degrees Fahrenheit over that time period. I also want to look at this from a distribution framework because it's good to put it all into perspective. Each one of these standard deviations is about a 1.7 or 1.8 degree framework. And note that for California in general, since 1995, only 99, 2010, and 2011 have been below our most recent kind of climate normal period. 2010 was right here, was about 1.6 standard deviations below normal, while 2012 through 18 were 2.3 to 3 standard deviations above normal. If If you want to put 2019 in perspective, it was right at 1 standard deviation above normal. So it wasn't anywhere near what we saw in 2010, but it was still cooler than what we've seen in the past 6-7 years. If you go to precipitation, I think Nova had a little bit of a conversation in there as well for precipitation. This was one of the wettest years the continental United States has ever seen, second wettest. And this was especially evident in the upper Midwest. Lots of snow, lots of heavy rain on snow, and lots of flooding in the early part of the year, and then a pretty wet Mississippi and Ohio River Valley. We had California above average. A couple of years in a row now, it's been more or less above average, while the Pacific Northwest, Texas, and the Southeast were all drier, below average. If you look at annual precipitation, again, looking at the same kind of thing for California, I just wanted to make a point here that while temperatures tend to trend, rainfall does not historically. We have had some seasons in some regions where rainfall is trended just a little bit, but it's not a significant kind of framework in terms of how things are changing. I also wanted to kind of pull this into play. This gets at a little bit more of the detail I think that Nova was going through here. This is a little bit complicated diagram. Right-hand side y-axis is the average temperature departure from normal. Normal being a 30-year climate normal, 1981 to 2010. And the lines you can reference there, the gray lines are the day-to-day departure from normal, while the black line is the weekly underlying kind of moving average. And then the red line indicates the zero line. On the left-hand axis is precipitation. Of course, they're in blue bars. And there are a lot of things that I think were just said in the previous talk also can be told here. Number one, the winter last year was overall warmer than average, 1.9 degrees Fahrenheit. And we're probably just a little bit above that right now for this winter. Winter lows happened actually in the middle of November to also the middle of February. Those were the two coldest periods in the winter last year. We had 5 single-day rain records within this area, one in January and the rest of them were in February. We also had some extremely wide swings from mid-April through mid-June in terms of temperatures, going from relatively warm in April through a pretty cold period in May, and then followed by one of the largest heat spikes in June. There was also, as Nova mentioned, quite a bit of rain during bloom set, depending on location and variety where you were, so there might have been some definite impacts there. We had fairly average temperatures during the growing season, although it still ended up being 1.4 degrees Fahrenheit above average during the heart of the growing period. Growing degree days, as far as I can tell from all the data that I have, was up about 13% or so in this area. There were, however, very few heat extremes in 2019. We had 4 record maximum temperatures in early June, mid-August, and late September. But other than that, typically we've been seeing 6, 8, 10, 15 max records during a given year, and this year was actually quite few. We also saw a rapid cool down in September. That cool down happened all over the western United States. If you were up in Oregon and Washington, it was pretty extreme. It shut things down. We basically didn't have no additional heat accumulation after about the 15th of September. It was almost zip. But it happened down here as well. So we had this rapid cool down. And there were actually scattered frosts throughout the entire western United States in different periods in September, which of course could be quite a challenge. So what are some of these influences? Let me just kind of put them all into perspective overall. First of all, we had an extremely warm Siberian, Arctic, and Alaska region this past year. There were times when Alaska was warmer than we were in the western United States in many different locations. And that was because of the way the circulation pattern set up. We also had this very cold central North America. And those two things, I think, are what are really kind of push-pull in 2018 and 19 for our weather and climate. These major temperature swings, I think they were kind of a real challenge pretty much everywhere across the West. We had a very warm, dry summer, but everywhere had low heat stress. Minimum temperatures were up, but maximum temperatures were down. We had a very warm North Pacific, and I think this is where some of this is coming from. Anytime you have warmer than normal sea surface temperatures. There's more humidity in the atmosphere, and therefore minimum temperatures tend to be a little bit elevated. We had this intense heat followed by a rapid cool down in September, depending on where you were. That could have had impacts as well. And I think we'll hear from Thibaut in terms of some of that as well. And then from a perspective across the West, relatively large crop south, but relatively small crop in the north. The numbers haven't come out for Oregon and Washington and Idaho yet, but I bet everybody up there is somewhere between 15 and 20% down in terms of production. So this leads me to current conditions, because this can tell us a little bit about kind of where we're going. If we look at the oceans, this is a fairly recent, just last week's sea surface temperature anomaly showing us places warmer and colder. Right now, the North Pacific is tending to stay pretty warm, meaning that we have added moisture load to the atmosphere, also influences circulation to some degree. In the tropics, though, we've transitioned away from kind of this minor, moderate El Nino we had to a kind of a much more what's called neutral characteristics. Just means that it's not tending one direction or another. And if you want to see what that looks like compared to last year, here are the two maps for that. You can see where the tropics were much warmer last year. And I think some of that was adding again to that moisture level that we had in the atmosphere. But overall, the framework in the North Pacific is similar between the 2 years. We can look at kind of what that is showing us in terms of current conditions. This is a map of water year temperature departures from normal from October 1st through yesterday. And there's really mixed temperatures across the western United States. Most of California is warmer than average right now. Parts of the western valleys of Oregon and Washington are as well. But then when you start shifting a little bit more inland to some of the higher areas in the basin and in the Rocky Mountains, it's colder than average. Same thing for the water year. I know you have been watching the news and you probably hear everything saying we're in pretty good shape. We're really not in that good of a shape. I'm not sure why the media has a tendency to portray that. It's kind of that illogical hydrological drought situation. But anyway, I'm sorry about that joke. The issue is that we've had a pretty dry start, even though we've had pretty good inputs. We've had a dry start so far to the season. Parts of Southern California and into the Southwest have gotten quite a bit, but most everywhere else is pretty dry right now. And we'll look at some more California aspects here. However, there's a little bit of a return to rain to the Pacific Northwest, which I think might help things here overall. Snow water equivalents. As we measure snow within our mountain basins. I know you can't make out all the little mountain basins there necessarily, but anything in the green is really close to average. Anything in the yellows, orange, or reds are below average. And right now we're seeing average to slightly below average. And especially in parts of California and the Sierras, it's actually dropped over the past month or so. If you look at California's snow water equivalent, this is, I just pulled this down yesterday as well. Currently, we're averaging 43% of what we would expect to be there April 1st for snow water equivalent, which means we're pretty far down. We need a lot more snow input to make that up. However, we do have 75% of the snow water equivalent that we would expect to have for right now, which means that what's there is actually fairly wet and we've got a reasonable amount, but it's still less than we had last year at this time. I think there's still plenty of time for this, but the forecasts are not necessarily looking really good. Keep fingers crossed. This, I don't know if anybody's seen this here, but I tend to key off of this. This is called a Northern Sierra 8-station precipitation index, telling us kind of how years relate to each other as you accumulate from the first of the water year through. And currently right now, we're sitting really close to the 2017-18 winter. You can see we're still below, we're in that blue zone, which is below the average of long term. We're nowhere near what we were in 16-17, which was a really wet winter. Still early though. We can also look at the drought monitor. The US Drought Monitor does a really good job of kind of summarizing this on the regional basis. And right now, the US has a relatively low drought footprint, although parts of the West are pretty extreme. Four Corners has been kind of the most long-lived and most extreme drought, southern Texas as well. The Pacific Northwest is seeing moderate drought in my region. It's been quite dry, even though we've had some inputs of late. And we've had most of our drought concerns lowered in California, but it does not mean that they're over with. It's just this, I think this is a short term. When this US Drought Monitor releases its next version of this, I have a feeling we're going to see drought concerns in California go up. California reservoirs are running 68% of average for total reservoir capacity at this point, but 107% of historical group average, slightly more than last year at this time, and this is a water management decision. People are holding back a little bit more water right at this point, probably on fears of longer term kind of issues. And again, we still have time for rain input, but we really need the snowpack. So this kind of all leads me to, given the current situation, what do we kind of gain from that in terms of looking at the spring and into the summer? So if we tried to tie this together in a forecast, an overall framework, first of all, we've had some pretty substantial variability in weather and climate through 2017 and 18, pretty much globally. We know, though, however, that persistence in the climate system would tend to tell us that we're still probably going to see some pretty evident warming. The Met Office in the UK has already released their projections for 2020, and they're overall putting our 2020 year to be within that green band in terms of its overall projection. So it's putting us still in that same kind of framework of where we've been overall. However, I do have to mention, there's a wild card out there. If you've heard of the volcano Taal in the Philippines, I've seen a few people shaking their head. The last time we had did I say hurricane? Okay, good. Some were in the back of my head, I thought. There actually has been a hurricane or a typhoon named Taal, so that's why I kind of somewhere in the back of my head messed that one up. But Taal's a volcano, and this may be the first volcano since Pinatubo in 1991 that could have a serious impact on our overall climate. Pinatubo muted temperatures globally by just over a degree in 1991. So if Taal keeps erupting and keeps erupting the same kind of material into the same part of the atmosphere, it actually could lower global temperatures over the coming year. But we have to kind of watch that over time. It can't just be one eruption, it has to be longer term. We also know that weather and climate extremes will likely continue. Most of our forecasting agencies are pointing to the northern plains and the southern tier states having the largest potential. We know that spatial extent of drought has definitely declined, especially in California. However, there's some current concerns for long term. We've had this warming Arctic situation, I think, which is really driving a lot of what we've been seeing of late. I mean, even this past winter, we had a period of time where Seattle got about 8 inches of snow while it was 76 degrees in Boston. Those kind of real dramatic kind of swings back and forth across the continent are really driven by some of this intense variability that we've seen in our flow patterns across the United States. The Pacific in the northern reaches, I think, will stay much warmer than average. This should continue to drive minimum temperatures based on higher humidity levels. From a forecast perspective, I mean, I'll take this for what you want. When NOAA releases this, I think it's really important to understand that when we see a map like this for temperature up above and precipitation below, basically what they're trying to say is that the evidence right now tilts the odds to it being either warmer or drier or colder or wetter. And so right now, March, April, May indicates that we have a greater chance for a warmer than average west, but I think there's going to be some, of course, month-to-month variation. Most of what the hint is there is that February, March looks warmer than average, April might cool down relative to average, and then May might ramp up from there. If you look at precipitation right now, California in the Southwest is likely to stay dry until April, when April will be a little bit wetter than average, and the Pacific Northwest and Gulf Coast are probably going to be somewhere about average overall. So this is, taking that in perspective, the U.S. also releases these seasonal drought outlooks. This is the drought tendency currently right now. This was released January 16th. I have a feeling the next release will probably inch that yellow area a little further down into California, probably even covering most of the state, which indicates that drought development is likely. Of course, the Four Corners is likely to stay, and so will the Pacific Northwest. So putting it all into a forecast, and I'm going to just kind of summarize everything I've just talked about for the Western U.S. overall. The tropics have kind of moved into this neutral stage. I don't think they're going to be a big player in terms of things we might see coming for the rest of the winter and into the summer. The North Pacific is definitely warmer than average, higher humidity, higher minimum temperatures likely. We currently have indication in our models that the atmosphere might be doing a very split flow framework over the west, meaning that storms will be shunted northward and southward and we'll miss out. And that's kind of the concern that everybody has right now. If you look at this in terms of what it's tilting the odds to, California should be warm, dry, late winter and transition to a slightly cooler spring and then recover pretty quickly. Pacific Northwest, a little bit different. We'll probably have a little bit more of an average late winter transitioning to a cool, wet spring as well. If you look at analogs climatologically are basically trying to take conditions currently right now and look at things in the past that were very similar and then try to see how are those conditions going into the spring. If we do that, we see that these conditions tend to indicate that spring frost frequency and severity tends to be higher in these kind of years, and especially as you move further inland and further northward. Growing seasons with these kind of conditions tend to be a little bit warmer. There's nothing indicating that this shouldn't be a period where we're coming into a kind of an average year based upon the last 6 or 7 years of data. And increasing drought concerns, both in the Pacific Northwest, are really a concern for, of course, my area. But I think there's late season decline in snowpack over the entire western United States for us to be concerned about. So with that, I very much appreciate it. I do want to mention something, and I don't know if I mentioned this before here. I've been writing a monthly weather and climate report for the entire western United States for about 20 years now. If you're interested in getting it, go to this website here. And on the left-hand side, you can scroll down and look for monthly weather and climate reports. And it's a little bit Oregon-centric, but it's really West Coast perspective overall. So with that, I thank you very much.
Thank you, Greg. So we have some time to take a couple of questions. There's going to be people running around with microphones so that everyone, it's for two reasons, so that everyone can hear what your question is, and so we can help also capture it for a recording. And speaking of those recordings, we should have these videos back to you in about a week's time. So if you're looking to kind of recap on what Greg just went over, or actually most of our speakers went over, we should have that back to you relatively shortly. So can we take a couple of questions? Actually, there's a lot more online, so.
Okay.
Hi. So you mentioned warming sea temperatures off the coast, and I'm just curious about the interaction of the temperature there with the increased humidity and the fog influence up and down the coast of California.
Sure. And we have to think, and I'm not going to go back through the slides just real quick, but the broader issue along the western United States with fog is that it's what's happening within the first maybe 100, 200 miles offshore. And we have a tendency to have much more upwelling of colder ocean there. That's what really produces the fog. But if you think about it, if you have out in the Pacific, if you have a plume of ocean water that's much warmer than normal, and then you have an area in the coastal zone which is a little bit cold, which it typically is, as the air moves over the moisture stuff, it picks up more moisture, then it moves over the colder water, and that makes fog more dense. Does that make sense? So that's kind of where I think we are a little bit. The upwelling does vary kind of seasonally and over periods of time, but it looks to be that I think that upwelling is going to play a role this year, but the further out really warm water should add more moisture to the atmosphere.
So there's a couple of good questions that were left on the Slido. And I'm going to start with the last one that was most recently made. Do climate forecasts correlate with wildfire forecasts or potential? If so, what do 2020 climate forecasts indicate for effects on wildfires?
This is a really difficult one. The issue is that, climate clearly does drive vegetation. That's pretty clear. But the conundrum there is that when you have a really wet winter, you have a lot more younger undergrowth of vegetation. And then when it dries out, then it has a tendency to provide more fuel. So that's kind of a challenge. These kind of forecasts don't tend to really drive fire season forecasting, but it tends to indicate. And we've seen it in the past couple of years that it's pretty clear. If we have really dry conditions, we can have some pretty catastrophic fires. But if we have really wet conditions, we have the fuel there to help start fires as well. I think the biggest thing is that it's people. It's everything we do. We're the real drivers of this. You guys don't get a lot of thunderstorms here. Lightning caused fires in the West are actually pretty minimal. It's mostly human-caused fires. And so that's and we can't forecast that, that's for sure. So.
Okay, and when looking to models for future temperature change, what models do you use, and what is the anticipated increase for the region in 20 to 30 years?
Okay, so most climate science has moved to what is called ensemble modeling. Ensemble basically means that we don't rely on one individual model. Everybody in here could create your own climate model, and we would all prescribe it slightly different. So you would all end up with a slightly different result. But if we took all of our climate models together, all of our knowledge about how the system works, and we looked at the ensemble, that ensemble is better as a result than any one solution. Does that make sense? Okay, so that's what climate scientists do. I tend to look at an ensemble of 10 to 15, maybe 20 models, depending on region and availability. And if you look at that, then you can get a range of what is the mean ensemble look like, and then also what is the range between models, okay? The ensemble for the Western United States for the annual period is for 20 to 30 years pointing to about a 1 to 1.7 degree Fahrenheit warming, but the warming is projected to be greater during the growing season, 2.2 or something like that degrees Fahrenheit, and also drying during the growing season. We don't get a lot of rain in the Western United States during the growing season anyway, so dry is dry, but still warmer, drier conditions are what are forecast.
Okay, how wide were temperature swings in spring 2019?
How wide? I wish I could go back to it. We had departures of in the Western United States, we had departures from April to May to June that were 15 to 20 degrees from normal. So if you had, if I see if I can get my bearings straight here, June 11th was about 18 degrees above normal, but you went 10 days before that and it was about 16 degrees below normal. So you had about a 30 plus degree above below normal swing overall.
Okay, and the final one that I have on Slido right now is, how does the 2020 ocean temps compare with drought years?
With drought years? Typically, drought years tend to have more cold water, and La Nina type of influences in the tropics tend to be cold water. Plus, if the North Pacific's cold at the same time, those tend to be the droughtiest years we have.
Okay. Anyone else have any questions they want to ask Greg? Thank you very much, Greg.